Hey, y'all, let's get solving of linear equations. We're going to start with the basic process. I'm going to make multiple videos here for you. And as you're going through this, there's a couple things I want to give you a heads up on. There's some things on the paper that I'm going to change and be like, oh, don't do this. It's not good math. We'll call it etiquette. The reason I say that is because I find that the things that I'm going to tell you don't do this is because I find that students make more mistakes when they do it as opposed to the way I'm going to show you. All right. And we'll start that off here in just a moment. The other thing I want to let you know is down here when we get to some examples, I'm going to do more than one type of example. So say like B down here, there's going to be two different ways I do this. And I want you to understand, possibly even three. I want you to understand that you are not required to do all three. You are to find the method that makes sense to you and use that. So when we get to that point, I'll be like, okay, hold on. Don't write anything down that I say. Watch what I do. And then whichever method makes the most sense to you, possibly two of them, write those down. Okay. So I just want to preface that it's not going to be there's always at least two ways to do a math problem. Always. So because I want to show you more than one way to give you more options. Both are right, or all three are right. There's just different concepts that I want you to see and give you an option. All right, so let's get started. The addition property. It's the same value or expression can be added or subtracted on both sides of an equation. So I talked about this before when we did our foundation piece, to where you hit an equal sign in between it. You have to do the same thing that you do to one side to the other. Otherwise, it's no longer equals. Here's what I don't like about this. I hate the fact that they put it in a straight line. I do not want to see you doing this. I find that it can be very confusing. And honestly, I see a lot of mistakes happen when people do this. So we're going to cover this up and not do it. I'm going to take that x minus 5 is equal to 16. And the goal here is to solve for x. So the question I always ask myself is who's attached to x and how? So 5 is attached to x by this negative, or it's subtracted from x. So we have to find what is the opposite of subtraction. Well, if you think of order of operations, it's addition. So because this is subtraction, we're going to get rid of it. We have to add 5. Well, when we do that, this goes away and we're left with x over here. But x doesn't equal 16. We can't just do this to one side of the equal sign. We have to also add 5 to the other side of the equal sign and only combine the 5 with other terms that are like. So 16 plus 5 is 21. And there is your answer. Okay, you're going to add 5 to both sides. This, I'm going to look at it. Let's push this up here. I don't have to look at it. The next thing is the multiplication property. If a number, 6x, is equal to 24, we want to, again, solve for x. Yes, I know those of you who know your multiplications are know it's 4. Yeah, it is. But we're using something simple so that you can understand the process. All right. So if 6 is multiplied to x, as it is, because it's right next to it, there's no plus sign or subtraction sign in between there. And because there's no operators in between it, it's multiplied. So if 6 is multiplied to x, the opposite of multiplication is division. So we're going to have to divide both sides, like they're doing here, by 6. I like to do it myself. All right, so we're going to divide both sides by 6. 6 divided by 6, anything divided by itself is 1. That's why we divided by 6. So this goes away and we're left with x. So it's 1x equals 24 divided by 6 is 4. The answer is not 4. The answer is x equals 4. Get comfortable with doing this, because if you just answer 4, That is wrong. This is a sentence. This is the sentence that says that x is 4. All right. Steps to solving. You've got to simplify each side of the equation separately. You have to distribute. You've got to combine your like terms. Then you use the addition property to get all the variables on one side, all the terms with variables on one side, and then all the terms with constants, no variables, on the other side. And then you're going to use the multiplication property to divide both sides and get the variable by itself. All right, check your answers if you want to. If we wanted to check up here, we could go 21 minus 5, and that does equal 16. 6 times 4, that does equal 24. My dog, she stinks so bad. She's got, ugh, yeah. Old woman. All right. So let's go to x plus 8 is equal to negative 15. We want x isolated all by its little lonesome. And I need to know who's attached to x and how. 8 is attached to x by addition. What is the opposite of addition? Subtraction. So we need to subtract 8, not just from one side of that equal sign, but also from the other. All right, so this is gone. 8 minus 8 is 0. We're left with x on the left. Bring down your equal sign, equals, and then the signs are the same, so we add them and keep the sign. So negative 15 minus 8 is negative 23. Okay. This next one, I'm going to want you to pause your writing and just watch. Choose what you want to write down afterwards, but for right now, just watch. Okay. We're dealing with fractions. That's another reason why you just want to watch. The first thing I thought of initially was I want to multiply both sides by the reciprocal, which is the flip. Keep, switch, flip, it's the flip. So I'm going to do that first. I do that because I can just multiply both sides. If it's 1/3, I can multiply both sides by 3 over 1. Because what you have to do to one side, you have to do the other. This is 3 multiplying by 3 over 1. Multiplying both sides by 3 over 1. This will reduce and give me just 1 over 1, which is x. 3 times 3 is 9. That's one way. I'm going to give you 2 more ways to think about this. Okay. The next one I want you to think about is if you have, I'm going to come up here, 1/3 x is equal to 3. What is the lowest common denominator? I know I'm probably speaking French. What is the number in the denominator? It's 3. We only have 1, so I only need to know that. I can multiply both sides of the equal sign by 3. To me, this is an easier way to see this. These reduce because this is over 1. You're left with, again, x is equal to 9. There's one more method I want you to see. This is probably the one I would want you to go with it. And then the last one I want you to see is another one you're going to want to write, probably this one and the next one down. What if I wrote, instead of 1/3 x, I write x over 3? That's the same thing. 1/3 times x is x over 3 is equal to 3. So that's the question. Again, I would multiply both sides by 3. These reduce, you're left with x is equal to 9. You decide which ones you like. If this one, cool. I would probably write these 2 down. I think those are probably your good basics to understand. All right, now we've got fractions again. Hopefully you paused the video and went back. Again, I can show you 2 different ways. One, we need to find our lowest common denominator. We've got denominators of 3 and 4. So our lowest common denominator is 3 times 4, because they don't go into anything else, and that's 12. So I'm going to multiply each side of the equal sign by 12, or every term by 12. So 12 times negative 2/3 x is equal to 12 times negative 1/4. All right. I'm going to go ahead and reduce. This is over 1. 12 divided by 3 is 4 times negative 2x. 12 divided by 4 is 3 times negative 1. 4 times negative 2x is negative 8x. And 3 times negative 1 is negative 3. Divide both sides by negative 8. and x equals 3/8. That's probably the way I would do that. That's what I would probably recommend for you. I will show you the other way. Do not feel as though you have to write this down, but I do want to just show you. I'm going to rewrite the question. Negative 2/3 x is equal to negative 1/4. And I'm going to multiply both sides by negative 3/2. It's the same sign, but the reciprocal or the flip of the fraction. You have to do it to both sides. On this side, you end up getting 1, which is x. This becomes a positive. 1 times 3 is 3. 4 times 2 is 8. Again, your choice on which method you want to use. They are both great in different ways. Last one on this page. 4x is equal to 14 minus 2. Well, these are the same. These are like terms. So we need to combine these. And that's 4x is equal to 12. Now, who's attached to x and how? 4 is attached to x by multiplication. So I have to divide both sides by 4. And x is equal to 3. All right. Next victim. So this next one, I want you to combine like terms first. You'll notice that 21 is by its little self over here. So looking at this side, we've got two terms that have x in it. We need to combine those before we move forward. Before I start moving things on either side of the equal sign, I need to get all my terms combined that are alike. 9x minus 8x is just 1x. So that's x plus 6 is equal to 21. Now, 6 is attached to x by addition. Opposite of addition is subtraction. So we're going to subtract 6 from both sides of the equal sign. This is gone, and you're left with x is equal to 21 minus 6 is 15. All right, come on down to F. Again, there's two different ways to do this. Again, there's two different ways. And honestly, you should know about both. The first one you definitely need to understand is as soon as I see this, I automatically think, oh, we need to distribute. We need to distribute that because this 3 is multiplied to x minus 6. So we need to multiply 3 times x and 3 times negative 6. 3 times x is 3x. 3 times negative 6 is negative 18. Bring down the negative 24. Now, I need to get my x's on one side, my constants on the other. So I'm going to see that the 3x, I can't divide by 3 yet. Not until I get rid of this term. If you think of order of operations, this is backwards. We have to add and subtract before we multiply and divide. You're undoing a package, basically. So 18 is subtracted. We're going to have to add 18 to make it 0 out. And we're going to add 18 to the other side as well. This is negative. This is gone, and you're left with 3x is equal to negative 24 plus 18 is negative 6. Now, 3 is attached to x by multiplication. The opposite of multiplication is division. Divide both sides by 3, and x is equal to negative 2. I want to show you the other method. I'll come up here. 3x minus 6 equals negative 24. Now, this method you can't use all the time. You're going to do this more often than not. So if you understand this, fantastic. Just sit back and watch what I do. I see that this 3 is multiplied to this. What's the opposite of multiplication? Division. I can divide both sides of the equal sign by 3. This goes away, and I'm left with x minus 6. Negative 24 divided by 3 is negative 8. 6 is attached to x by subtraction, so I need to add 6 to both sides. X is equal to negative 2. Just another way to do it. All right, this one you cannot do what I just did. You have to distribute. No other options here. So 7 times x, 7 times -3, and then I'll have to do 4 times 3x and 4 times -2. 7 times x is 7x. 7 times -3 is -21. Bring down your +5. 4 times 3x is 12x. 4 times -2 is -8. And bring down your -8. Do not start moving things on either side of the equal sign until you've combined all like terms on both sides. On this side, we need to combine -21 and 5. On this side, we need to combine -8 and -8. 7x minus -21 plus 5 is 16, -16, and then 12x minus 16. Now I need to get my x's on one side, my constants on the other. So I'm going to subtract 12x from both sides. This will be gone. -12 plus 7 is -5x. Bring down your -16 equals -16. -16 or 16 subtracted from this, so we need to add 16 to both sides. -5x, this is gone, is equal to 0. Now we're still solving, so we need to solve for x. We're going to divide both sides by -5. And x is equal to, put it in your calculator. 0 divided by any number, as long as it's not 0, is 0. 0 divided by -5 is 0. Now, what if, I know this is not the case now, but what if instead of having x is equal to 0 over -5, what if we had x is equal to -5 over 0 or any number over 0? Put it in your calculator. You'll get a syntax error. You'll get something, or the most important thing you need to understand here is it doesn't work. So this is undefined. X is undefined. If you've come across anything like this in My Open Math, you'll use DNE. I just want to make sure you knew that. It does not exist. All right. Let's come back up here to H. We've got to distribute 5s and our 6s. 5 times A is 5A. 5 times -2 is -10. Bring down your -15. 6 times 12 is 72. 6 times -7 is -42. All right. Combine like terms on either side of the equal sign. Don't start moving across the equal sign yet. So these two need to be combined, and both of these need to be combined. Oh, I should never have done this. What was I thinking? You should never distribute. You should never distribute like this. I was so wrong. I mean, it's fine, but students tend to make most mistakes this way. Instead, what I should have done, can I show y'all? 6, 12 minus 7. I should have gone 12 minus 7. Order of operations, PEMDAS. Start with parentheses. 12 minus 7 is what? 5, right? Yeah, 5. So 6 times 5, which is 30. So this side should have just been 30. I'm going to go ahead and combine this side. All right, now I need to get my A's on one side, my constants on the other. So I need to start by getting rid of that 25 that's attached to 5A. I'm going to, it's subtracted, so I need to add 25 to both sides. This is gone. 5A is equal to 55. 5 is attached to A by multiplication. The opposite of multiplication is division. So we're going to divide both sides by 5. A is equal to 11. You're going to hear me saying the same words over again. And the reason for that is because I want you to say those words to yourself when you're doing your homework. Say those words to yourself when you're doing the practices. Who's attached to A and how? If it's subtracted, you add. If it's added, you subtract. If it's multiplied, you divide. Okay? If it's divided, you multiply. That's it. I want you to start thinking that way. All right. Looks like some distribution here. Nothing's constants all the way. All right. So distributing this negative and distributing this negative. Remember, if there's no number out here. It's always an assumed 1. Put the 1 there if you need it. It's not going to hurt my feelings. 4 times 3x is 12x. 4 times -2 is -8. Negative times a positive is a -6x. Negative times a negative is a +5. 6, negative times a positive is a -3x, and a negative times a positive is a -1. Now, combine like terms on both sides before you start moving stuff around. I'm going to combine my x's, my constants, and then my constants. 12x minus 6x is 6x. -8 plus 5 is -3. 6 minus 1 is 5, minus 3x. Now, I can start moving things around. I want my x's on one side, my constants on the other. I'm going to add 3x to both sides, put it directly below your x. That's 9x minus 3 is equal to 5. I need to get rid of this -3, so I'm going to add 3 to both sides. Gone. And then 9's attached to x by multiplication, so I'm going to divide both sides by 9. And x is equal to 8/9. All right, that is it for this lecture video. I will see you in the next one.